Welcome everyone to the soldering workshop, and today we'll be soldering some surface mount and through-hole components on this FM transmitter board. I'll start with an example of what happens if you don't apply enough heat to the part that you're soldering. The solder can't stick to the cold metal and won't make a good connection. This time I'll wait for the copper penny to heat up. I'm going to put a small amount of solder between the tip and the surface to help with heat conduction. I'm also going to point the soldering iron at a level so that I can have the most amount of surface area touching the copper. But we can do even better using some flux. The flux cleans up all the residue and oxide built up on the surface and helping the solder flow even better. There is some flux built into the solder itself, so you don't have to go crazy with it. Now that we've defaced some currency, let's move on to the real thing. So I have my PCB board double-side taped to a bigger piece of cutting board, and that'll keep it from moving around too much. Also, it might be a good idea to place those SMD components on the double-sided tape as well. The first step in soldering SMDs is to apply a little bit of solder to one of the pads as an anchor point. Since this particular pad is so small, I'm going to put some solder on the tip of the iron and just touch it to the pad. Next, align the part with the pad, reheat the pad until the solder melts, and leave it for a few seconds until everything melts back together. For the other side, apply a drop of flux and then come in with a tiny bead of solder and it should cling right on. You don't want to use too much like I did here, and having thinner gauge solder will definitely help with that as well. If you're not satisfied with the way your joints turned out, you can always come in with a fresh cleaned tip and rework those joints. Just a quick note, this inductor should be placed with the black painted side facing up. Otherwise you'll have a much harder time soldering them in place. Next I will solder resistor R2, which is the one labeled 102. And since the pad on this device is so big, I'm going to just heat up one side of the pad and make sure I'm feeding solder to the pad and not the iron itself. So same as before, heat up both the part and the pad until they melt together and hold it in there for a few seconds so that it really bonds together. Don't forget flux. So right here I put the solder on the soldering iron instead of on the component, but with enough flux it ended up working out fine. So this next capacitor came in really crooked, and I wasn't able to fix it by reworking it with iron, so I decided to remove it by heating up both of the pads and just starting over. Right now I'm using some desoldering braid to wick up the excess solder on one of the pads so I can start over. Now that we're done soldering all the surface mount devices, I'm going to dunk the board in some rubbing alcohol and brush it with some old toothbrushes to get all that flux residue off. Next I'm going to put the transistor in and bend the pin so that it won't fall out when I flip it over to solder it. Just remember to put that soldering iron so you can heat up both the pad and the pin and apply solder to the area once it gets hot enough. And I'm just going to use these cutting things to trim off the pins. And same deal with these big capacitors. Just make sure you have the correct polarity by lining up the negative side with the white paint on the board. Now I solder in the battery clip and the audio line. So I really done goofed up on this one. Clearly you can see that the pads are way too small for this capacitor. Luckily I did find a way to solder it back into place on the other side. It just so happened that the emitter pin of the transistor and the positive of the electrolytic were spaced just perfectly for this trimmer cap. And that's it for this workshop. Bye.